Welcome to Almost Here, Round the Corner Future Technology podcast with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more.
Hello, this is Richard Jacobs with the Future Tech Podcast. My guest is Doron Pinhas. He's the CTO of Continuity Software. So, Doron, how are you doing today?
Pretty good, thank you.
Yeah, tell me about Continuity Software. What's the premise of the company?
Sure. So we started the company some 14 years ago with the mission to help large enterprises provide 24/7 computing services, as it were. And since that time, the demand is only rising.
So what kind of computing services, like 24/7?
Right.
I mean, with the internet, I guess everyone assumes computing services are 24/7 anyway nowadays. But
sure, obviously, right. So we know the problem is probably universal. If you open a shop and it becomes successful and you're dependent on online sales services or call centers, you obviously want to have the infrastructure up and running 24/7. We focus on the top tier of the market. So just to give you some sense, 4 out of the global 10 financial service organizations are among our clientele, and we work hard to make it 10 out of 10. So about 400 customers worldwide. All of them are Fortune 500 and their equivalent worldwide. So it's a specific target. And we look at very, very large enterprises. They tend to have tens of thousands to hundreds of thousands of servers across multiple continents, dozens of states, and so on, and making sure that they can retain services becoming more and more challenging. So regardless of whether you're an airline, a financial service, a retailer, and so on, customers have grown to expect everything to be always on.
So,
Make sense?
Out of all the services possible, what are the main services that you see people have a need for during off hours?
Right. Well, just to tickle your imagination, and the examples I'm providing are not necessarily just out of our clientele. This can happen to just about anyone. We are following issues in the industry, as it were, closely. So if you look just at the last 12 months, you will find, just Google the word outage, and you will find that people were trying to get into a concert. They bought ticket online, and the infrastructure on premise that was there to make sure they can get in didn't function. So they had to cancel the concert, just a trivial example. Or we had about 10 of those incidents since the beginning of the year. Airlines break down, there's an IT meltdown, customers get stranded. Sometimes it's just for hours, sometimes it's for 2 or 3 days. So that's very, very common. These are examples of services that deeply affect end users. And yet one other example in Europe, generally speaking in the UK, it has been a very, very bad year for financial services companies. And TSB Bank, one of the largest in the UK, had a series of IT service outages, which meant customers couldn't access their funds, couldn't pay online, couldn't book to hotels. And because it happened frequently enough, the CEO had to step down. And when you follow the news, there are some estimates made to what they've managed to lose during those incidents, and the numbers are well above 100. Some even claim 200 million pounds. So the implication of not having your computer systems up and running 24/7 can be quite serious, and it's getting tougher over the years. So if you look into the industry as it was 10 years ago, people were used to having internet sites down. They would just try again the next day. You could have stepped into your bank and find that they have a technical issue and they'll kindly ask you to step in the afternoon. Today, it's unacceptable anymore, and people are much more connected. And if something goes wrong, within 5 minutes, you'll find tens of thousands of pings in social media. And if in the past you've seen companies ignore it, today you see the CEO stepping online and explaining what's happening every 5 minutes. So it's becoming more and more critical to enterprises to make sure their services are online.
Okay. So, what size companies do you typically deal with? Is it more large companies or do small companies even need this as well?
Yeah, so the problem of having your compute infrastructure up and running is common to tens to hundreds of thousands of companies worldwide. We focus on the top tier, Fortune 500s, whether these are financial services, telcos, large retailers, online dealers, and so on, airlines. Basically, anyone who cannot afford to have downtime and data loss and has a large enough and complex enough IT infrastructure, information technology landscape.
Okay. All right. Any particular types of applications that are, more critical for these large businesses than others?
Well, sure. So when you look at the as a business, right? If it's a very large business, then they typically have anywhere between many dozens of different applications to well over several thousands, right? One of our large financial services has about 13,000 different applications. And not all of them are created equal. Some of them will be as trivial as managing the fax services, others will be online banking, yet others will be whatever, retirement management. So each and every application within an enterprise will typically have its own priority. And enterprise tend to classify them. So there are always those tier one applications that must be online 24/7. For example, whatever ATM services and access to your funds. You need to be able to do that 24/7. But then there are systems that need to support customers during business hours. So they typically classify the different applications by the priority and severity. And typically you'll find that 10 to 30% of the applications are very critical, and the rest tend to move down towards some applications which are used just once a month or even once a year to run some analytics and build strategy for the next fiscal year. So there are definitely different application priorities, and they vary by the enterprise type, right? So for airlines, it would be the ticketing and systems, and second would be the sales systems, and third will be whatever the surveying application, in which they'll just send you an email afterwards and ask how was your flight. So each enterprise will have its own priorities, as it were. Now, when you look at the mission critical applications, what you'll find is that it's elusively difficult to make sure they are up and running all the time, right? So if we'll imagine a small business, we are starting up, we are purchasing a server, installing an application that we use to whatever serve our end users, and we kind of realize over time that it needs to be up and running all the time. And every now and a while we'll have a power outage or our communication line fails. We'll start looking into building more redundancy. So the first steps will be to add redundant power supplies and potentially buy two communication lines and two routers. And then maybe add a second computer. So if the first one fails, we can fail over. And it grows more and more complex. So following the story I told for just one server, we went up from one computer to at least 2 or 3 different types of redundancy: power, networking, yet another computer. Now, when you look at an enterprise with 500,000 servers that support 10,000 different applications, the picture gets increasingly more difficult. There are millions of moving parts you need to take care of just to make sure everything is running all the time. Now, the problem with all of those controls is that they are only put to test when something really bad happens, right? So if you drive a car and you have a spare tire and you have a flat tire, you go back to the trunk and figure out if you have that spare tire and if it's in good shape. And if it's not, then you're really down. So you spend, as you've purchased your car, you spend some money on building redundancy. You'll test it when the time comes. So how often did you go back to your trunk and take a look at your tire just to see that it's still there and that it has enough air, right? So in IT, it gets much, much more complex.
Okay. Well, what are some of the top issues that cause outages that you see for large companies?
Right. So it's always the more interesting outages are always a combination of more than one factor because the simpler ones are kind of obvious, right? So just to give you an example from, I won't mention the airline name, and there's actually more than one that suffered a similar experience, but an airline went down in the last 12 months for about 2 to 3 days. And what they mentioned as the reason for outage was that a router failed. Okay, so, and as a result, they went down for 3 days. Now, in reality, while I'm absolutely certain that they did have an issue with the router, that does not explain the real problem. When you look more closely into the anatomy of an outage, you'll find that there are more complexities, right? Because when you look at the airline, they probably had more than one router. So if one failed, another one should have kicked in instantly. So it couldn't have been just the router. So when the router failed, traffic had to be redirected to some other servers, and that didn't work. So, well, what does that mean? That they didn't test, that they didn't set it up correctly. In another incident, we've heard a company saying, well, a power grid broke down and several servers got fried. And so now we had an issue that spanned 2 days. Well, again, when you look at it more closely, then in a large enterprise, you'll have multiple data centers. Each one will have redundant power supply. So when a power supply fails and some servers fry, there are others in the same building that should fire up instantly, meaning zero downtime. The fact that it didn't happen means that something there went wrong. Now, they don't usually stop at that because they also have servers in a remote location in a different geography, sometimes dozens or even hundreds of miles away, that should also be able to kick in. Now, that wouldn't be instant. It may take several minutes. So that also didn't work, right? So a single point of failure can cause a difficulty, but there are usually multiple layers of defense that are put in place when you build a tier one IT service that should kick in. And usually when you see an outage, what it means is that there was a systemic failure to design and test all the layers holistically. So the power grid failed, some servers fried, the ones that should have kicked in didn't work, so that's another failure. The ones that should have kicked in remotely didn't work as well, which means either it was not set up correctly or not tested correctly. So there's usually a cascade of issues that lead to the failure. It always begins with the weakest link. In the two examples I provided, it was the router failing or power grid failing. But either way, the real problem is that resiliency and redundancy in the IT infrastructure was not designed all the way through. And by the way, the examples I provided are from traditional technologies used in the legacy data center, and many people move today to public cloud, right? So it's interesting to know that the same problems happen in the public cloud as well, right? So you'll have customers running on AWS or Azure or Google Cloud Platform or any combination thereof, and they still have outages. So the fact that you migrate your IT stacks into more modern tiers doesn't make that easier to fail. So in reality, there are actually thousands of things that can go wrong to bring systems down. IT systems are pretty fragile and they're susceptible to a lot of entropy. So for example, when you run your own home PC, every now and a while you'll notice that it's updating itself once a week, twice a week. If you have 50,000 servers, you will typically find thousands of servers being updated every day. Now you also have to upgrade your software, and some of the servers retire after 3, 4, 5 years of service. If you have 50,000 of those, then it means you change about 10,000 each year. You have 50 weeks, so it's 200 a day, whatever. So I'm probably wrong with my math.
Crazy.
But a lot of things happen, and they're usually done by multiple teams, right? So you have the server team plugging in the new servers. And if you're in the cloud, you have your DevOps teams fire up new virtual machines. So the mechanics are different, but you then fire up new workloads. They need to talk with the application guys who need to work with the database administrators. Usually there are also consultants and contractors and vendors chipping in. Now, a lot of humans need to coordinate how you set up those systems for resiliency. And don't quote me on that, but humans do not communicate perfectly. So you do a lot of change with people who may miscommunicate. And the last bit of complexity is that the technology itself keep on evolving, right? So we are mentioning cloud infrastructure. So both Amazon and Microsoft and Google constantly bring more and more features. Like AWS published, I think, more than 1,500 new features just last year. People have significant challenge in catching up with the technology as it evolves. So usually when they deploy something new, there is always the small risks they are actually not doing it by the book anymore. So and even if you try to automate everything and build very very precise and tidy processes, the innovation may catch up with you ultimately. So as you combine all of those factors, hundreds to thousands of changes a week by dozens of different teams who do not necessarily communicate with technologies that keep on evolving, it's no wonder that it's kind of difficult to make sure that in each and every point on the way you did absolutely no mistakes. Right. So maybe you've added more servers,
It
but
makes
they're
you
not
wonder
connected
how
correctly.
anything runs, you know?
Right. So now, in order to bring order to this, so it's a very chaotic process with a lot of entropy, just like in anything in nature. Entropy is very high, especially because you combine multiple different factors. Each one can derail stability. Now, this is, by the way, not unique to IT. Years past, I was pretty close to the airline industry. If you look into whatever modern jets, sometimes these machines are not supposed to fly at all. They have the center of mass um, too way behind, right? So they should potentially crash instantly. But you have constant computing processes running in the background, making infinitely small corrections. So it remains very, very stable. Now you can get better maneuverability and so on. So a lot of systems, and I would argue, if you'll have more time, that the human body works in a similar way. You have lots of moving parts. Each individual component that may break can put the entire system at risk. And for that reason, you'll see in nature, biology, and in some technological areas, controls put in place to bring order back, right? So when you look into a manufacturing company that produces very high end and high quality products, you'll see that they use a lot of automation. Nothing is done manually, but they also have particular attention into quality control. So you can figure out if something went wrong either on your design or actual assembly and so on. So these particular controls to make sure everything gets back into shape are not as developed in the IT industry as it were. So people will do all of those changes, design to their best ability and knowledge, but in many cases, what we find is that there is no feedback loop to tell them if what they've done was correct and to thoroughly enough look at what's happening after every change. And that's basically where we started from. We've created a technology to help humans manage resiliency in IT infrastructure in a much more comprehensive way. If that makes sense, I can maybe speak very, very briefly about what it is that we actually do.
Yeah, let's get into that because we talked a lot about the background and the industry, but
Yeah,
let's get a few specifics.
sure. So IT is fragile, and you try to do the right things, and it may break. So what we have created is a technology called Availability Guard, and we are working on some new exciting products. I mean, if time allows, I'll potentially mention them a little bit later. But what Availability Guard provides, first of all, is the ability to discover how your different IT components and IT layers were actually set up. It's entirely agentless, so you don't have to install anything. We can step into an extremely large enterprise, deploy our software on one or more servers. It can scale up to any size of an infrastructure you may want, and within a single afternoon, have it ready to run. So what it does from that point onward is to communicate with existing management protocols that the different technologies I mentioned earlier, like servers and networking and computing and storage and high availability and load balancing and what have you. A lot of technologies used to build IT. They all have APIs, and Availability Guard uses those APIs to read the configuration data. So extremely quickly, it can detect how your IT infrastructure is set up and it automatically discovers the high availability and resiliency and disaster recovery patterns. These are some of the terms used in IT to describe how you build resiliency and redundancy. So within a single afternoon, you have your first visual map showing what was deployed and what was intended. But the really interesting bit starts next because Availability Guard is a deep knowledge platform. It contains a huge repository. To date, we have about 8,000 different signatures, we call those signatures, of potential problems that can occur in IT as a result of ongoing changes, modernization, and upgrades that will lead to the failures I've just mentioned. I've mentioned just 2 or 3, but there are thousands of things that can go wrong. And the tool brings a huge amount of human experience. So we work very closely with all the major vendors out there, whether that's IBM and VMware and Amazon and Microsoft and Oracle and I'll the apology of all of the other vendors I've mentioned. So they have inch-thick books with best practices for resiliency, each one of them, and they get published every quarter or so. So our job is to work with the different vendors and capture their recommendation for maximum resiliency. So that contributes to about 70% of our knowledge. And we also work with hundreds of very large enterprises to learn what kind of problems did they run into as they were building an infrastructure and seeing less than optimal resiliency. So we add all of that knowledge to a huge repository. And what Availability Guard does is just immediately after connecting all the dots and figuring out what you have tried to accomplish, it then compares it to the knowledge base. And if some problems in your design or deployment manage to slip in through the cracks, the tool will immediately show you where do you have vulnerabilities, what do you need to do to fix them, and it starts measuring resiliency from that point on. So it's basically a toolkit to help the large enterprises monitor how they're doing, and when they're not doing right, figure out what's wrong and how to fix it, and get the dashboard to improve.
Well, very good. Well, Doron, we're pretty much out of time, so let's give some references for listeners. What's the best way they can get in contact with Continuity and find out more, do an evaluation to see if your uptime systems will help them?
Sure. So obviously, a lot of info is on our website, www.continuitysoftware.com. There is also an interesting offering there to run a one-time health check. It's a service we provide for enterprises to prepare for the shopping season that's coming, or to the next tax season, or after they've made a major upgrade, figure out if they're doing right. And so there's a lot of material there in repositories. And of course, you can always reach out via email at info.continuitysoftware.com.
Okay, very good. Well, Doron, thank you for coming. I appreciate it.
Awesome. Thank you so much. Take care.
All right, hold on 1 second.
You have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.